Welcome to the Unit 2 test review for Math 030 Pre-Calc Clinic. I will be giving, out of the 20 questions, I will be giving basically 18 of them away. So it's a pretty good review video to watch. Make sure you have your notes in front of you and follow along as best you can. The first two problems are going to be about complex numbers, and they're pretty simple. The first problem will have us adding complex numbers, and you can think of I as a variable, even though technically it's not. I is the square root of -1, but it acts like a variable in this way when you add or subtract. We're basically just adding two complex numbers here, and so we're going to add the real parts together, and then we're going to add the complex parts together. So we have positive 1i and minus 7i to get 13 minus 6i, and that's it. Adding is just combining like terms, and you think of I as a variable when adding or subtracting. In number 2, we're multiplying. So when you're multiplying, you're going to distribute, aka FOIL, again. So we're going to distribute this 10 through first. When we do that, we'll have 30 minus 70i. Then we'll distribute this 1i through, and we'll have plus 3i. And then we'll have minus 7i squared. All right, we do have to remember that I squared is -1. That is because I is technically the square root of -1. And when we square the square root of -1, we get -1. This doesn't matter so much. This is what you have to remember. So I squared is technically a real number. It is -1. And so what I'm going to do in this next line is combine these like terms here. So we'll have the 30 still out front. Then we'll have minus 67i when we combine those two terms. And then finally, this last term I'm not going to do too much with, but I'm going to do this in orange here. So we'll have minus 7, and then I'm going to replace I squared with what it equals. It equals -1. So this term is really plus 7. So we have 30 minus 67i plus 7, which ends up equaling, when we combine these like constants here, these like terms, we'll have 37 minus 67i. For more examples like this, check out the videos in the 030 playlist for adding and subtracting complex numbers and multiplying complex numbers. That goes for any of these topics. You can check out those videos. Number 3 on your test is going to be solving a quadratic, which we've done already, but in this case it's going to have complex solutions, meaning there'll be I. That means that under the square root, when we use the quadratic formula, we'll have a negative number. So we do have to remember the quadratic formula. Definitely have it written down. Opposite of b plus or minus b squared minus 4ac all over 2a. The quadratic formula works for any quadratic if you're asking to solve or trying to solve. And when factoring doesn't work, like here we can't factor, here we can't factor, quadratic formula is your best bet. All right, so let's take a look at number 3. A here is 1. A is the number in front of x squared. B is -1, the number in front of x. And C is 5. All right, so when we have those three things, I'm going to plug into the quadratic formula here. So we will have the opposite of b, so +1, plus or minus, giant square root. Then we're going to square -1 to get +1, minus 4 times a times c all over 2a. Simplifying the discriminant, which is the number under the square root, will give us 1 minus 20. So we'll have -19 under the square root all over 2. All right, remember that I is the square root of -1. Therefore, we can break apart the square root of -19 into the square root of 19 times the square root of -1, which equals the square root of 19 times I, which is I root 19. We just write the I out in front. So when we keep going with this, we'll have 1 plus or minus I root 19 all over 2. And the way you want to write this on Alex is because it's two answers. You'll write one with the plus sign, comma, one with the negative sign. So these are our two answers. Okay, for this next problem, go ahead and write down number 4. Try it, pause the video, and then click play to check and see how you did. Right here we have complex solutions once more. Our A, B, and C are listed. Plugged into the quadratic formula, we end up getting -3 plus or minus I root 39 all over 4. Now, if this was a root that could be broken down further, we would do so, but in our two examples, 19 and 39 are both numbers that cannot be broken down any further. So we can write it in Alex. You want to write it as two separate answers, that's just how they prefer, separated by a comma. So we're just breaking apart the plus or minus sign to show literally the two different solutions to this quadratic. Okay, the next two I think are a lot easier, I think just because factoring is probably easier than that stuff, but we are going to be simplifying these rational expressions, or these rational expressions by factoring. And let's take a look at number 5. The first thing we want to do with factoring is take out a GCF if there is one. So in the numerator, our GCF is 2x, and then what we have left would be 10 minus 3x, and we can't factor 10 minus 3x at all, so we're done in the numerator. In our denominator, we also have a GCF of 2x, and we're left with 6x plus 1. These two x's can cancel, so we're left with 10 minus 3x over 6x plus 1. In number 6, we can first factor out the GCF in the numerator, and the GCF in the numerator is 4. When we factor out the 4, we're left with x squared minus 4, and that can actually be factored further. This is a difference of squares, so this will factor to 4, and then we'll have x plus 2, x minus 2 for our difference of squares. In the denominator, this is a quadratic trinomial. There's no GCF here other than 1, so we can't take anything out. But the two numbers that multiply to -8 that add to 2 are going to be x, they'll be plus 4 and minus 2. So x plus 4 and x minus 2. And then we see that the x minus 2 factors end up canceling. So our final answer will look just like this. All right, there are a few problems, there are actually quite a few problems on your test that involve domain. And we have to understand that domain and excluded values are kind of the same thing, except they're opposites, which is kind of weird. But domain is all the values that x can be, and we find all those values that x can be by finding what has to be excluded and literally taking it out. So they're along the same lines, but they're opposite. So one of the questions that you're going to see, or actually two of the questions that you'll see, are going to ask you to list all of the excluded values. So this is literally just asking you what number won't work. They're going to be a fraction. We know that you cannot have 0 in a denominator. So we take a look at the denominator in number 7. What value of x makes that 0? The value is -2. So this is our excluded value. So -2 is the excluded value. We do not care if our numerator is 0, that's fine. -2 is the only excluded value. All right, let's take a look at number 8. The denominator is a quadratic, so we know that there's going to be potentially two answers that make that one 0. So we want to think x squared minus 9 equals 0. What makes that 0? Well, we can solve by factoring, or we can just straight up solve it by doing the square root. When we take the square root, we'll get plus or minus 3. So our excluded values are -3 and 3. because they make the denominator 0, and therefore they need to be excluded from the domain. Again, we do not care. We wouldn't say -1 is an excluded value because it makes the numerator 0. The numerator being 0 is completely fine. We just have to, the denominator being 0 is not okay. Problems 7 and 8 also deal with domain, and in this case they're asking us to find the domain, so we're going to want to write it in interval notation. They both will have a square root involved. Now we know with a square root, what's under there has to be 0 or greater, because we just can't have negatives under the square root in the real number system. So we want to take what's on the inside here, and we want to force it to be greater than or equal to 0. And when we solve just like an equation, except if you multiply or divide both sides of the inequality by a negative, then you'd have to flip the sign. So we found that x needs to be greater than or equal to 3/2. We need to write this as an inequality. So our domain is that x can be 3/2, so we include it with those brackets, and it can be everything greater than. So positive 3/2 included all the way to infinity. Try number 10. Go ahead and pause and then hit play to check. All right, for this one we did have to flip the inequality because we divided both sides here by a -1 to solve for x. So in this case x has to be less than or equal to 5, therefore our domain is from -infinity up to and including 5. All right, the next couple involve both a fraction and a square root. Let's take a look at number 11. We want to find the domain here once again. So immediately we know what our excluded value is. We take a look at the denominator. What value of x will make this 0? This one's very easy to look at and see. X cannot be 5. So we know, I'm just going to do a little scratch work off to the side. We know that x can't be 5 because it makes the denominator 0. Okay, now we're good with the denominator. The numerator, we just talked about what we had to do here. So in order to find the values that x can be, we have to do x minus 3 is greater than or equal to 0. So we find that x must be greater than or equal to 3. All right, so is that an issue with this? Yeah, it is. X can be everything greater than or equal to 3, but it just can't be 5. So let's take a look at this on a number line just to be a little bit visual here. All right, so x can be 3, I'll do this in orange here. X can be 3 or greater, but it can't be 5. So I have a little hole there. So basically, in order to write this as an interval, we can start at 3, because that's the smallest we can be, but we can only go up to 5, but we can't include it because x cannot be 5. Then we put a union because we're jumping over 5. So we're here. We're jumping over it and traveling all the way to infinity, since we have no more issues. That's our domain. All right, same deal with number 12. Go ahead and pause the video, press play to see how you did. Okay, here's our domain. The value that made our denominator 0 was 1/2, so x cannot be 1/2. Okay, we're done with the denominator. We take a look at our square root here in the numerator. We have to force it to be positive or 0. So we solve the inequality, see that x needs to be greater than or equal to -1/5. Therefore, the smallest value we can be is -1/5. That's where we start. We can equal it. We have to jump over 1/2 though. So we can only go up to 1/2, not include it, and then we can go all the way up to infinity. Okay, the next two problems actually deal with function composition, and I put them in two different sections here. So the first part is function composition with a number. So in the first one, we're going to find f of g of 2, and I'm going to rewrite this as f of g of 2. Okay, this is the same thing as this. I like writing it like the second way because it looks nicer. So I'm going to find g of 2. What is g of 2? That means I have to plug 2 in here. This is really a -1 out in front, so I'm not taking -2. I'm doing 2 squared first, then multiplying by that -1 out in front. So it looks like this. So it's 4 times that negative out in front. All right, so this really means I'm finding, it means I am finding f of 4 because I replaced g of 2, I found what it was, and it should be -4, my bad. -4, there we go. All right, so g of 2 is -4, so I'm finding f of -4. How do we do that? We plug in -4 here. So we'll have -16 minus 3 equals -19. All right, go ahead and pause the video and try the next two. Go ahead and press play to see how you did. All right, for these next two, we have g of f of 2. We find f of 2 is 5. So g of 5 is -25. F of h of 13, we find h of 13, which is 5. Then f of 5 is 17. Problem number 11 also deals with function composition, and I'm using the same 3 functions again, but now we're plugging in, not technically plugging in x, but we're not plugging in a number this time, so we won't get a number out, we'll get a new function out. So you'll not only be asked to compose 2 functions, you'll also be asked to find its domain. All right, so when we're finding f of g of x, once again I'm going to rewrite it, so we're finding f of g of x. So I'm now going to plug in g of x into f of x. So I'm plugging in -x squared into here for f of x. So I'll have 4, and then I'm going to plug g of x in, and then -3. G of x is -x squared. So this was the orange that that was the orange that I plugged in. All right, let's simplify that. I want to do this 4 times this -1, so we'll get -4x squared minus 3, and that's it. That's our function. Now because we've created a new function, we do need to identify its domain, and this domain does not have any, this function has no restrictions, no x under a square root, no x in a denominator, therefore our domain is all real numbers, negative to positive infinity. Okay, go ahead and try h of f and also find its domain. Go ahead and pause the video, click play to see how you did. Okay, we are plugging in f of x, which is 4x minus 3, into the h of x function for x. So we'll distribute the 2 through to get 8x minus 6, and then we have the -1. Combining like terms gives us the square root of 8x minus 7. Since x is under a square root, we do have a restriction on our domain. We just did this in a few problems previous to this. So here's our domain. Okay, the next problem, number 12, also deals with domain, but it deals with domain and range on a graph. So you do have to be careful when writing in interval notation. When do you have the open parentheses and when do you have closed? The open parentheses means you have an open circle somewhere. And the closed parentheses means you have a closed dot, or you are hitting the actual point, like here. Okay, so let's take a look at this first graph here. I'll do this one in orange. Domain, we're going to look left to right. So our leftmost x value is -5, and our rightmost x value is 7. And we actually take on those values, we hit them. So our domain is from -5 to 7 inclusive. Our range, our lowest value, y value is -2, and our highest y value is 4. There's no jumps or skips or anything. And we actually hit those 2 values, so we'll have them closed as well. So -2 up to 4. Okay, in our second graph, we'll do that in pink. Our domain, our leftmost point is over here. That x value is -4, and we do take it on. It actually hits there. And our rightmost point, our x value is not quite 3. We'll say 3, but we have to put, it's open, so we're going to put open parentheses around it. So this goes from -4 closed to 3 open. And then our range, same idea. Our lowest y value is going to be an open -5, and our highest one is going to be an open 5, since they're both open circles. All right, problem number 14 has you simplifying a rational exponent. And just as a quick recap, If you have x to the a over b, it means you're taking the b root of x and then raising it to the a power. So let's do that for the first problem. 4 is our base, and we are taking a second root of it, or a square root. So we're taking the square root of 4. You don't need to write the 2 here. We automatically assume it's a square root if you don't put a 2. And then we're going to take that to the 5th power. Okay, so the square root of 4 is 2. 2 to the 5th is 32. All right, go ahead and try the next two. Go ahead and hit pause and then hit play to see how you did. All right, these next two both had us taking cube roots since 3 was in the denominator. And then in this case, we'll get 2. The cube root of 8 is 2. Squared is 4. Here we're taking the cube root of 125 and then raising it to the first, so our final answer is 5. All right, numbers 15 and 16 are dealing with quadratic inequalities. So these are both quadratics, right? There's something squared, but instead of equaling 0, it's going to be an inequality with 0. And we're going to need to utilize a number line. All right, the first thing we want to know is what are our important numbers? So what values make each one of these 0? Okay, those are going to be like just our important numbers. I don't really have a name for them. Okay, I'm going to make a number line. And as you can see, the value that makes this 0 is 1. And the value that if we plugged in for w, that would make this 0 is -8. So those are the two numbers I'm going to put on my number line. -8 and 0. Oh, sorry, and 1. Okay, they make 0 if we were to plug them in. So this is going to be our w value down here. That's the value of w. And this is like the output. What would it make if we plugged it in here? It would make 0. I want to know, when are we a positive number or 0? So I'm going to plug in a number in this section of the interval and see what happens. Then I'm going to plug in a number that lies in between. Then I'm going to plug in a value that lies to the right of 1 and see what happens. I'm looking for when this is greater than 0, or when we get a positive number. That's what I care about. So let's plug in a number that's to the left of -8, say -10, okay, something over here. If you plugged in -10 here for w, you would get a negative number here. I don't care what number it is, because I only care if it's positive or negative in the end. If you plugged in -10 here, you would also get a negative number. Therefore, when you multiplied those two negative numbers, it would yield a positive result. That positive there means that anytime you plug in a w value that's less than -8 over here on the number line, you'll get a positive value here. That's eventually what we want. All right, let's try plugging in another number. Let's plug in a number in this interval here, in between -8 and 1. What's a number that lies in there? Well, 0. 0 lies in between these 2 points. So if we plugged in 0 for w, we would get a negative here, because we'd get -1. And if we plugged in a 0 for w here, we'd get an 8, which is a positive number. And if you multiply a negative times a positive, it gives you a negative result. Okay, there's one more interval to go. A number that is greater than 1. Let's try 2. If you plugged in 2 here, you would get a positive number. And if you plugged in 2 here, you'd get a positive number. So a positive times a positive is a positive. What we want as our final answer is, I want every time this gave us a positive number, right? Greater than or equal to 0. So I want all the answers that lie here and all the answers that lie over here. I don't care about this middle part because it's not giving us what we want. So our final answer is everything that lies on the interval, this interval, and this interval. Those intervals are -infinity up to -8 and 1 all the way to infinity. Now, what type of thing should I put around -8 and 1? Do I put open parentheses or do I put closed brackets? Check this out. It's or equal to 0. That means we also want to equal 0. We could plug in -8 and 1. We want to include them. So we'll put brackets. This problem, I feel like in the past has perplexed students. So I would recommend checking out the short video that I did that went a little more in depth. All right, let's try the second problem, the one in yellow. This one first needs to be factored. So we'll have x minus 5 and x minus 3 is less than 0. We have those two numbers because that's how that one factors. All right, so our important numbers here are the values that make that 0, the values that make this 0, which are 3 and 5. If we were to plug those in, they output a 0. Okay, so these are x values down here, and these are the outputs up here. All right, let's plug in a number that's less than 3. Let's try the number 1. If you plugged in a 1 into this parentheses, you'd get a negative number. And if you plugged a 1 into this parentheses, you'd get a negative number. Negative times a negative. That means we get a positive out over here. I want you to try these next two. Pick a number in between here, see what you get, positive or negative, and pick a number over here, greater than 5, see what you get. Go ahead and pause the video and press play to see how you did. Okay, you should have a negative here and a positive here. Now let's take a look at the kind of answer we want. In this problem, we want all the values that will give us a negative number. We want things that output to something less than 0, not even equal to 0, just less than. So we want this interval in between 3 and 5 because that gives us what we want, a negative answer. So our answer is between 3 and 5. We want to use open parentheses because we do not want to include 0 as an answer. We cannot include 3 and 5. Only the values in between that output a negative number. Problems 17 and 18 deal with simplifying exponential expressions. Number 17 will look something like this, and number 18 we'll get to in a second. That has a negative exponents in it. When you simplify an exponential expression, you need to write each variable only one time and use all positive exponents. So the first thing I recommend doing is simplifying on the inside of the parentheses. Can that be simplified at all? And the answer is yes. 3 over 2 can't be. There's no other x's, but this y to the 4th over y to the 8th can be simplified. There are 4 more y's in the denominator, so we can write this simply as 3x squared and then 2y to the 4th. That's because when we subtract 8 minus 4, we'll get 4. When you subtract, you just do the larger minus the smaller, and wherever you started is where you end up. And then that's still raised to the 3rd power. Okay, then we're going to raise everything to the 3rd power. 3 to the 3rd, x squared to the 3rd, and 2 to the 3rd, and y to the 4th also to the 3rd. When we do that, so we'll have 3 cubed, 27, and then x squared to the 3rd, so raising a power to a power will multiply, so we'll get x to the 6th, over 2 cubed is 8, and then y to the 4th to the 3rd, by that same rule, would be y to the 12th. Okay, go ahead and try the problem in pink, and pause, and then hit play to see how you did. Okay, you can check your answer here. So I simplified b to the 8th over b to the 1st, and we got b to the 7th. Then we squared everything, 2 squared and 5 squared, 4 and 25. And then a cubed squared is a to the 6th, and b to the 7th squared is b to the 14th. Okay, problem number 18 will look like this, a little more complex with some negative exponents going on. So the first thing I want to do is simplify on the inside of the parentheses. We'll subtract, starting with the bigger number for our x's. So we'll have negative 1. I'm going to do this off to the side. We'll have negative 1 minus negative 5. And to simplify these x's here, we'll subtract the exponents. And so that gives us, this is really a plus, right? So that gives us a 4. So when we simplify this, x to the 4th ends up being on top. We'll have y to the 4th over 5, because I simplified the x's there through subtracting. All right, then it's still all raised to the negative 2nd. And raising something to the negative second means what we can do is flip all of this. A negative exponent means flip. So the way that I prefer doing this is to just flip everything. So the 5 will go in the numerator, then the 3x to the fourth, y to the fourth will be in the denominator, and it's just raised to the positive 2. From here, it's not that bad. It's what we've already done. So we'll have 5 squared, we'll have 3 squared, then we'll have x to the 8th, y to the 8th. All right, go ahead and try the problem in yellow, and then you know the drill. Okay, the first thing that I did is simplified our a's and b's by subtracting. So I took the larger number and subtracted the smaller one, starting with a in the numerator and b was in the denominator. When we did that, that's where our final answer ended up. So it was a to the first and b to the fourth, still raised to the negative third. When something's raised to a negative exponent, it means flip and make the exponent positive. So we flipped, raised everything to the third power in order to get our final answer. Okay, the last problem that I'll be doing is solving a rational equation, and this is the easier one. It's not going to get into a quadratic. It'll be a simple linear problem to solve. So the first thing we want to do is factor any factorable denominators. So this one can factor into 2 times x plus 5. And then we can clearly see what our LCD should be. The LCD, least common denominator, should be each one of the denominators, each factor, listed one time. So 2 and x plus 5 is our least common denominator. All right, so we need all of our denominators to look like that. So as we can see, this first term already has that denominator. So we don't have to change this first term at all. It's negative 3 over 2 times x plus 5. But this second one only has a 2, and it doesn't have anything in the denominator. It has a 1 technically. So we need to make this look like 2 times x plus 5. So we need to multiply the denominator by 2 times x plus 5, and then also multiply the numerator by the same thing. Finally, our last fraction only has x plus 5 in the denominator, so we need to multiply that by a 2 to make it look like our LCD, so we need to multiply the numerator also by a 2. Okay, now that our denominators all are the same, we can be rid of them. So what we're left with here is a negative 3. Here we're left with a 4 times this quantity, so it's going to be 4x plus 20 when we distribute, and equals 6. Then we'll simply solve, so I'll combine these like terms over here, and then we'll subtract to get our final answer of negative 11/4. The only thing we have to make sure of is that the value that we get doesn't make our original denominator 0. The only answer of x that could make that denominator 0 is negative 5, and we did not get that as an answer. So our answer of negative 11/4 works. And that is the entire review. I went over 18 of the 20 questions that you will see. The other 2 are similar to stuff you've been doing on Alex, nothing crazy new. But if you feel like you need more review on any of the certain type, feel free to go to that specific video, search elsewhere, practice again on Alex, whatever you need to do. Good luck.